Nowadays, like deep learning systems has become an essential part of the complex software systems. For example, image classifiers are used to diagnose disease, or self-driving car agents are using like sensor information to drive a vehicle. And because of the safety critical nature of these systems, ensuring their robustness is but unlike traditional software, the behavior of deep learning systems are not coded directly, and it is learned from the training examples. And because of this fundamental difference of deep learning systems with traditional software, testing these kind of systems is more complicated, and it is difficult to understand to what extent we can rely on these systems when they are deployed in the real world. So several approaches in the literature try to test deep learning systems. I'm just providing some examples of these approaches. Most of these approaches focus on generating adversarial inputs by adding perturbations to the original inputs. For example, DLFuzz manipulates raw input and generates adversarial inputs. Or DeepJanus is a model-based approach that characterizes the quality of the system using its frontier of behaviors, and finds like pairs of inputs that can trigger different behaviors of the system. Also, Asphalt is a search-based approach for generating challenging virtual scenarios for testing self-driving cars, and its output is like out-of-bound episodes. So a limitation of these approaches is that their output cannot be directly used to explain the behavior of deep learning system. For example, consider these two handwritten digits. One of them is correctly classified by the model. However, the other one is misclassified. And relying on the existing approaches, we don't have enough information to understand what high-level features of input might have caused the model to misbehave. While such an explanation is useful to help developers for debugging and improving deep learning systems. So our solution and like our suggestion was to propose to explain deep learning systems using feature maps. In this picture, I show you an example feature map, a handwritten digit for the handwritten digit classifier. So x-axis is discontinuity, which indicates how discontinuous the stroke of handwriting is, and y-axis is boldness, which indicates how strong the stroke of handwriting is. And the map cells contains the most challenging input for each corresponding feature combination. And here, relying on this feature map, we can say that like very thin digits are hard to classify by the model. And on the other hand, when the digit is very bold and discontinuous, it can, for example, in this feature map, which was for the digit 5, they can shape and look like 9 and make the model to misbehave. So this is actually what I meant by high-level human understandable features to explain the behavior of deep learning system. And but for generating these feature maps, first we need the features. So a crucial element of our approach is to choose dimensions for the feature space, to define the feature space, and these features should be representing meaningful properties of the test cases. So to this aim, we propose and adopt a novel systematic methodology that can be used to define the features. I will not go to the details of this methodology, just to give like brief explanation. It's like a human-based method. So you should have like a couple of human experts for your domain, and then they should identify features and also find some metrics that quantify those features. And then you can have like features to explore the feature space. So it's like involving with the human experts in the domain. Then when you have the features, you can start to explore the feature space using illumination search. Illumination search is a type of search-based approach, and it's named illumination search because it's illuminating the fitness potential of the feature space. So here, for example, this is like a feature map with 2 feature dimensions, and the color of the map indicates the performance value. So the darker means misbehavior and lighter means correctly behaving inputs. So the algorithm works like that. You have to initialize this map with your feature dimensions, and in each iteration, you select an occupied cell and mutate it using mutation operators, and then you can compute the features for newly generated input. And then you find like the corresponding cell to put that feature, that input. There would be a local competition between the newly generated input and if there is occupied with another input, and the one that has highest performance would be placed in the map. So this iteration would be repeated until the determination budget. You reach a termination budget, which could be a time or like the number of iterations. So here the fitness function for the search-based algorithm is the closeness to misbehavior. And originally, illumination search designed to use random selection. So in each iteration, we randomly select one of these cells and mutate the individual, which we developed a tool, deep Hyperion, based on that. But we were thinking that maybe we can select individuals more wisely and explore the feature space more extensively and generate more misbehavior inducing inputs. So we came up with the idea of using rank selection based on contribution score. So instead of randomly selecting a cell to be mutated, we select a cell that contains an individual which contributed to exploration of the map more. And actually, it was successfully exploring the feature space better. So for this study, we evaluated our approach on two deep learning systems. One of them is MNIST, which performs the classification task and consists of recognizing the handwritten digits from the MNIST dataset. And the BeamNG system solves a regression task, and the self-driving agent predicts the steering angle of the car given the images of the camera. So for as a first research question, we wanted to see that if we can effectively explore the feature space, and we performed an experimental evaluation and we compared our approach with the state-of-the-art approaches. And we defined a metric to this, which was the number of field cells. So we count that the number of cells in the feature map that are covered by different approaches. And here you can see, for example, like abstract of the results and our illumination-based approaches, which are deep Hyperion contribution score and deep Hyperion, were able to cover the feature space more extensively than other approaches. For example, for MNIST, 3 times more than other approaches. Also, another important thing for our study was about feature discrimination. So we were interested to see that how strongly different combination of the features can characterize the failure-inducing inputs. And here are like 2 feature maps that I am presenting, one for MNIST and one for BeamNG. In these maps, we use the cell color to indicate the average misbehavior probability across the runs for the tool. And so darker color means higher probability of misbehavior. And if it is white, it is not explored by the approach. And the cells that are highlighted with the dark border are having misbehavior probability larger than 0.8. So in both cases, you can see multiple regions which are highlighted to have high probability of misbehaviors. For example, the map for MNIST suggests that left-oriented and teen digits are most likely to cause misbehaviors. Or like the map for the BeamNG suggests that disregarding the number of turns, when the car drives close to the lane margins, it can cause failure for the model. So this was like one of the important messages of this study, that we could explain the misbehaviors of deep learning systems based on some human understandable features. But then we said, like, yeah, okay, we have these feature maps which were human understandable, and we have the test generator which can generate tests and populates the feature map. But the thing is, deep learning, when these systems are deployed in the real environment, they can face this phenomenon of development to operation data shift. So the developers might need more inputs, like more different inputs, to improve the quality of their systems. So for example, we have these feature maps. Maybe developers were interested to generate diverse misbehaviors misbehaving inputs with critical features, which are like dark areas of the feature map. Or maybe they are interested to generate misbehaviors with the inputs features that do not seem critical from the gray areas of the feature map, or generate some misbehavior inducing inputs from unseen areas of the feature map. So to have like this setting, we decided to propose a focus test generator based on feature maps for the developers. So we basically proposed an approach named Deep Attach, which was like first focus test generator for deep learning systems, and it was a genetic algorithm which is optimizing three different fitness functions. The first first objective is we want some inputs that are close to the target that the developer wants to generate inputs. The second objective of our fitness function is that we want these inputs to be misbehavior inducing. And finally, we are not interested in the like repetitive tests, but we want them to be diverse. So we defined a genetic algorithm considering three different objectives for the fitness function to generate targeted inputs which are misbehavior inducing and still diverse. We have evaluated this approach on two deep learning systems. First, MNIST, and also the other one, which I explained before. And IMDb is a text classification task which predicts that the movie review has a positive or negative sentiment. And we compared our approach with the only state-of-the-art approach which can explore the feature map, and it was able to generate significantly more number of misbehavior inducing inputs on the targets, which are like the metric is the tests that are close to the targets. Moreover, one more thing that we could do with these newly generated inputs was to fine-tune the model to see that if we can improve the model using these inputs that we generated with focus test generator. So we used like part of the inputs generated by our approach Deep Attach and the original training set of the deep learning model, and we fine-tuned it for a couple of more epochs. And then we evaluated it on the original test set and the test sets of newly generated inputs. And the results show that while we were still be able to improve the accuracy of the model for both case studies on the original test set, we were able also to improve the accuracy on the newly generated inputs, which were initially zero. So all misbehaviors to achieve like 99% accuracy on the newly generated inputs. However, regarding the self-driving car, the results weren't that much promising. So because, like, as you know, testing autonomous driving systems is like resource intensive, and it requires expensive simulations to be run. And I think like the original algorithm spends most of the time on some unpromising areas of the feature map running the simulations, and that was why it wasn't able to find targeted inputs in those areas. So we decided to also provide an approach for generating focus tests for autonomous driving systems. And to overcome the limitation of the previous approach, we proposed a focus test generator that adopts a surrogate model. So the main algorithm is similar to the previous algorithm with the same fitness functions. The only difference is that during the evolution, we try to gather some data as training data. We run the experiments, like the iterations by the original simulator, and gather some data for training the surrogate model. After we have enough data, we train a surrogate model. And after that, instead of running the actual simulator during the run, we use the surrogate model. And only when an input is eligible to go to the archive as final output, we reevaluate it again with the simulator to make sure that the final archive that we are reporting are actually on the target and misbehavior inducing by the original deep learning model. And adopting this surrogate model actually helped a lot. And we managed to generate significantly more than the state-of-the-art approach on the target with this new approach, which for the autonomous driving system as well. We did the fine-tuning for that system too. So here, because it's a regression problem, instead of accuracy, we measure mean squared error. and we were able to improve the mean squared error on the newly generated test set and also the original test set of the model. So these were approaches based on the feature map that we had. But whenever we were presenting these approaches, the main concern of people were that, okay, yeah, these approaches work, but the problem is that how can we come up the features? So we need human experts to design the features manually for us. So it was like one of the limitations of these approaches that people usually concerned about. And we thought that, and like when the system is more complex, it is even more difficult to define human understandable and discriminative features for that. For example, like you consider real world images, it's very difficult to define features. So we decided to propose an approach which automatically generates features without involvement of human to tackle this limitation of the approach. We automatically generate features using this process. So we first use a feature extractor that can be original deep learning model or external feature extractor like VGG. And we extract this numerical vector of the features from feature extractor, and then using a dimensionality reduction approach, we can generate latent features, which they are like data points with reduced dimensions, and they are still retaining the maximum possible information. And using these latent features, we can again generate our feature maps. We have evaluated this approach again on like two case studies, MNIST, which was handwritten digit classifier, and a larger scale visual recognition case study, which is ImageNet. And in particular, ImageNet with 1,000 classes and large size real images poses a challenging task for the test generators. And because of the complexity of the images in the ImageNet, it is extremely difficult to define understandable features for these images. And as a research question, we wanted to see that while we have generated these features automatically, but are they still discriminative? So will they give us like information about the behavior of the deep learning system under the test? Can they group the misbehavior inducing inputs and the correctly behaved ones separately? So we defined the metric average cell impurity, which computes the impurity of each cell of feature map based on the behavior of the model for the inputs. And this metric is designed to be between 0 and 0.5. And here you see, like for both case studies, our approach was able to generate maps with very significantly low cell impurity. And we have results like for two different feature extractor, the original deep neural network and VGG model. And both of them were useful for extracting features, and they were able to generate highly discriminative feature maps. So although these features are automatically extracted, it would be useful if they were able to group the inputs in a way that is understandable to human. So we decided to do also a human study about these automatically generated features. We published two human studies, one for MNIST and one for BeamNG. And in this study, we provided the human with two groups of images. One group of images are selected only from one cell of the feature map. However, the other group is selected randomly from different areas of the feature map. And then we asked the human which group of images is more cohesive, so contains more similar images. They could select that which one is more cohesive or like they are equally cohesive. And 80 assessors answered this human study, 40 for MNIST and 40 for ImageNet. And we report the cohesiveness rate for the groups of images that are reported from the same cell of feature map and the ones that are randomly selected from different cells of the feature map, and if the assessors thought that there is no difference between two groups. And here you can see like 78% of the time assessors thought that the feature map one is more cohesive. So overall, assessors were able to understand higher cohesiveness of feature map cells. In fact, our study showed that misclassified images assigned to the same cell from a cohesive group of images can share substantial similarity.
And this might be like a future direction for some future actions like retraining or improving the system on these parts of the feature map. So to summarize, today I have talked about feature maps. So here are the references for the papers. We proposed Deep Hyperion as a first illumination-based search to explore the feature space. We also improved Deep Hyperion by introducing the notion of contribution score to explore the feature space more. We also applied Deep Hyperion for generating test inputs for drones in the cyber physical competition of the SPFD in ICSI this year, and it was one of the winners, and it was able to generate diverse misbehavior inducing inputs even for a drone system. I talked very abstractly about focus test generator that we proposed, which was originally for the classifiers, but we could improve it also using Stargate model for the autonomous driving systems. And I also talked about automatic feature extraction for deep learning systems, which can somehow tackle the limitations of the previous approaches. There was also another study which I skipped because it was too long to discuss. It was an empirical study to compare our approach with the explainable AI approaches, because there are already explanations in the literature that they are trying to explain the behavior of deep learning system in AI community. So we decided to also compare these two kind of explanations and see that if there is any complementary between them, and which one is more beneficial to use for your purpose. So you can, and it's published in ESM, and if you want, you can also check the paper. So before I finish my to conclude, I decided to also give some takeaways from my PhD, as I might consider my PhD as a success. So I would like to discuss some factors that I thought that they affected my experience during my PhD. I was thinking that maybe it would be useful for both PhD students and advisors to consider these factors if they want. So it's but a disclaimer, it's just my experience, and I will provide just examples of my experience. There are probably other factors can affect and the other ways of approaching PhD also might work, but this was my experience. So I will discuss couple of important factors. I guess the most important factor during the PhD is the advisor. So the advisor has significantly high effect on experiencing a good PhD. And some of the characteristics that I found impressive from my advisor, I am presenting here. So first of all, my advisor was very supportive and encouraging in all the steps of my PhD. So during our meetings, it doesn't matter that if I did lots of job, if I have lots of results or less results or even no results, he was always encouraging, supportive, and thankful for the work that I have done. So I guess this was somehow I would say a fuel to my engine, that I could be motivated more and next time to try to have better results, better output. So it's one of the most important factors, I guess, is to be supportive and encouraging, because PhD itself is already very difficult and with high workload, and being supportive is important. Another aspect that I think was very impactful was being well organized. So my advisor was very well organized and articulated and disciplined. So we had bi-weekly meetings set from the very starting day of my PhD, and we could discuss our ideas during these meetings. So we knew that we have this dedicated time to us to discuss the ideas, to brainstorm. And during these meetings, usually I provided some slides about my progress, the work that I have done during these 2 weeks, and we could discuss how we can improve different aspects or what are the future tasks for the next meeting. So being well organized is really effective in my opinion. Another aspect of the advisor which I liked a lot was being open to new ideas. So as a like a PhD student, discussing things with like some senior people, sometimes you need to be more confident to be able to discuss new ideas. So usually in my case, my advisor was very open to ideas that I was providing during our meetings, and he was polishing those ideas and shaping them better and giving back to me to continue the research. And actually it was like giving you the feeling that you had real contribution yourself, so it was really motivating. And yeah, so another aspect that I would consider important is being deeply involved. So yeah, my advisor was like very deeply involved in every details of my PhD work. So if I want to provide you an example which impressed me a lot, I remember like during early times of PhD, I didn't have any idea, for example, in one meeting about a statistical test. I never did it before. So I mentioned that, yeah, I don't know. I don't have any background knowledge about it. And I remember like right after our meeting, my advisor like sent me like a detailed email with explaining all the details about a statistical test with some examples and a Python implementation of himself for the statistical test that I can implement. So it was like he was also very involved in the implementation of the tasks, and like I could discuss like how can I optimize even like my algorithm, the implementation, in all the details of the work that we were doing together. So I guess it can really affect the output of the your work a lot. The second factor that I think is important is collaboration. So nobody is perfect, and other people can help us, and we can help other people. So we had during our during my PhD, we had this good setting of postdocs working with PhDs. We had this different work packages that we were working together with postdocs, which I found it very insightful and useful, especially in the earliest stages of PhD when you are not familiar with the topic, with how to write a paper, how to do research. Working with a postdoc really was helpful for me, and I had this opportunity to work with my colleague Vincenzo Riccio, like a direct postdoc, and I also had like experience collaborating with other postdocs from other universities. So we worked, like for example, with Adesio Gambi from Passau, which we had like a nice brainstorming time together. They helped me like in revising the papers, shaping the ideas, and also even in the implementations, they contributed a lot. So I appreciate this collaboration with seniors. On the other hand, there is this opportunity that I had the opportunity to working with master students and also bachelor students. It's a bit different experience because there are brilliant students and less brilliant students, but again, it's at the end is, I guess it's worth it to also dedicate like some of the workloads to the master students. They can help in the implementation if they are good, and also doing some literature review. And if they are not prone to get the job done, still you get the experience for your future work, especially if you want to stay in academia. It's again an experience. Another factor that I think it's important for the PhD is about selecting the venues and like finding the proper deadlines for you. So our approach during my PhD was that we were focusing on the quality over the quantity. So we never cared like about the number of papers that someone should have to graduate the PhD, but the quality of the papers that you give. So we usually worked on some ideas, and whenever we had like reasonable results, which we agree on it, we check for the top venues, upcoming deadlines, and the one that was more feasible to write the paper and submit. We approach that deadline. So there is no pressure to like some specific deadlines that you have to submit, and it's like I guess it helps a lot. And in my case, I had like very specific experience that beside being lucky, I almost had no rejections during my submissions, and only the last paper that I submitted like 1 month before my PhD got rejected from one of the conferences. But yeah, but it's like I don't want to bias you that yeah, that you have to face also rejection during the PhD. And if you want, I would suggest you check out the talk of Professor Gabriele Babota on reviews, regrets, and negative results in SI seminar last year. It was really insightful about facing the rejections and negative results. And finally, the thing that I think another factor that is very important for having successful PhD is like keep track of work-life balance. But actually, it's not about PhD. Like in every work, if you keep track of work-life balance, it would work. So I always try to have a to-do list for myself and organize my tasks, prioritize them, the most important one first, and it really helped me. And we usually have like regular breaks together with group, coffee breaks, lunch breaks, which helps a lot to recharge, rest. So you shouldn't put like lots of pressure. Yeah, I tried like during my PhD also I tried to exercise regularly and never quit the gym. Basically, even like before one day before deadlines, I selected to go to the gym instead of spending time on the deadline, and it worked somehow. And finally, you should like one thing that I did was like I tried to pursue my hobbies. So I liked a lot traveling and visiting nature. So I during my PhD, I guess like I traveled a lot of destinations in Switzerland, even like over a weekend. And I remember like first question that my advisor was asking my on the Monday morning was that where did you visit last weekend? So because yeah, I was trying to travel a lot. So I guess yeah, these were like what I wanted to talk about. So yeah, that was it. So thank you for your attention.